All right, we have a triangle here. It looks like BAC. The angle BAC is bisected by AD. That tells us something right away, right? And we're also told that 1 is congruent to 3, and we're supposed to prove 2 is congruent to 3. Okay? So our first step to every proof is the given. That's always our first step. Right? So 1 is going to be AD bisects the angle BAC. Now I'm not going to do the second part to that yet. I'm going to wait until I need it. Okay? And what I do here is I say, well, what did I do? Well, that's given. I didn't do anything. It was given to me. Okay? Change color. 2. What does this tell me? If AD bisects it, what does it mean to bisect, first of all? If I bisect something, Kiko, what am I doing? If I bisect an apple, what am I doing? Cutting it in half. In half. Exactly half. Right? So if I cut this in half, that means those are equal. Right? So, by definition, angle 1 is congruent to angle 2. By what? By definition of an angle bisector. Okay? By definition. These have to be congruent because I bisected it. I cut it in half. I cut this angle in half. Okay? That's cool. What else do I know? So, from 1, I know this. I can start my flow chart. 1, I started with. And from that, I went to 2, right? Now 3. What am I going to do with 3? Can I come up with anything from this? Well, how about I look at this, the second given. Angle 1 is congruent to angle 3. Given. So, because it's given, I'm not using something to get there, right? So it's all on its own. Okay? Can I come up with anything now? If 1 is 2 and 1 is 3, wouldn't these be the same? Wouldn't that make sense? Right? Think of it like this. If Jordan is native, and Kiko is native, and Dayton is native, right? Let me say that again. If Jordan and Kiko are native, right? And Jordan and Dayton are native, right? Then doesn't that mean that Dayton and Kiko are native? No. Right? I mean, it's just logical, right? What logic are we using there? That's the trick. Okay? We're using if A equals B and B equals C, then A equals C. That's the logic we're using. If Jordan and Kiko are both native, and Kiko and Dayton are both native, then Jordan and Dayton are both native, right? That's all. It's just logic. Same thing here. Which one's the same? The B's. So we want to put this as a B and this as a B, right? Now if B is equal to A or C, it doesn't matter, right? Then this would have to be A or C, but the opposite of the other one, right? Okay? And so now, if A is equal to B and B is equal to C, then what? Then A, right, is equal to C, or in other words, angle 2 is congruent to angle 3. And what did we use there? The transitive property. Okay? So, 4, we use the transitive property. So for 4, did we use 2 and we used 3 to get to 4? So I had to use both this and this. Okay? Flow. Flow chart. Two-sided proof. Two-column proof. Okay? Nice.